Now let's discuss about question 9, which is obtain basic logic gates from neural networks. Summarize them in table with number of neurons, activation function, backpropagation neural networks, if any. Right. So now let's discuss about question 9. Here our objective is to obtain basic logic gates from neural network. So first we can obtain this using a simple perceptron model, that is a Boolean logic that gives either a 0 or 1. Right. So perceptron model for logic gates, that is, let inputs be output, that y belongs to 0 and 1. We are always getting an output value that is 0 or 1. Now based on that, we use the combination of weights and biases and a activation function. Our activation function represent non-linearity in our network, right? Now this non-linearity is done using, it can be done using many activation function. First is sigmoid function, which is 1 upon 1 plus 1 upon 1 plus e to the power minus x. Then we also have radial basis function. There are many functions. For this video we will be covering sigmoid function. So let's say we have to build a AND gate. So let me show an image. For AND gate, we are taking different features and weight has to be 1 for those all those features. We are taking bias value as minus 0.5, and here is our activation sigmoid function, which is 1 upon 1 plus e to the power minus x. Based on that, we compute the output, and when we found the output, it gets same values as and, where for two ones we get 1, and for either 1 or 0 we get 0. This behave as a AND gate. Now for OR gate, we should get output when at least one input should be 1. So similarly, this is also done. Here we apply the weight as all, for all the features we have weight as 1, and again bias minus zero point 0.5. When we apply it, let's bias will be minus 1.5 for OR gate, right? So when we apply this, we get for any of the input is 1, we get OR gate and we get the output as 1, right? And for NOT gate, which is a single input, we let's say for we take the weight as minus 1, we take the bias value as zero point 0.5, and we put this on in our activation function, which is sigmoid function, and we get the value. For 0 we get 1, for 1 we get 0, right? So this is a neural network implementation of logic gates. Now let's see B part of this question. Compare CNN, RNN, uh, adversarial network, and transfer learning in terms of architecture and application. So let's discuss about this. We have CNN and RNN. CNN means convolutional neural network, which have a different convolutional layers, which perform filters, sliding over input, nonlinear activation function, and pooling, and typically followed by dense layer. Here, what is done by one convolutional layer? We try to reduce the matrix, and though the resultant matrix is further reduced by other matrix. Now, where we need matrix for image, basically for image classification, object detection data, right? For image data, we represent image as a binary data, that is binary matrix, that is 0 to 1. And based on that, we have application that, for example, object detection, face recognition, and it is also used for spectrograms and natural language processing, right? Then we have recurrent neural network that is built on sequential data. So hidden state at time t depends on previous steps. Its implementation, the model that follows this implementation is LSTM, that is long short-term memory architecture, that uses the concept of memory, where it we store the previous value or previous output of the data. And for application of recurrent neural network, we have natural language processing, machine translation, sentiment analysis, speech recognition, finance, stock price prediction, chatbots, and so on. And let's discuss about GAN. GAN is nothing but general adversarial network. And it consists of two components, basically a generator and a discriminator. Generator tries to fool the discriminator to, and discriminator tries to correctly classify real versus fake. Application are image processing, image generation, deep fakes, where our faces are faked, right? And MRI enhancement and medical imaging application and computer aided designs, right? Now let's discuss about its architecture. We have a discriminator, we have a generator. Here generator creates fake data based on inputs and send it to discriminator. Discriminator finds if the data is real or fake, and based on that we also provide real data to discriminator, and based on that fake data is provided by generator, and based on that it identifies if the data is real or fake. Now when this whole process is performed, it could lead to better image generation or better image synthesis, right? So this is an architecture of general adversarial network. Then we have transfer learning. Now, what is transfer learning? Transfer learning means using a pre-trained model on a new but related task instead of training from scratch. Now, for example, I am building a AI model which links the internship opportunities for the skills provided. Like, so instead of building a model from scratch, I will use a model, a BERT model or sentence BERT model that understands the meaning of word, that understands the semantic of word, that convert those words into word embeddings or into vector data, so that I can easily use it and fine tune it. Fine tuning means using it for my application, that is AI based allocation engine for our this feature, right? For predicting the opportunity for mapping the internship opportunities based on relevant skills, right? Now for application, we have AI vision face recognition, medical AI, disease classification, NLP, chat GPT, sentiment analysis, robotics, object detection, and agriculture crop disease detection. Yeah, this is our common major application of transfer learning. So yeah, this covers our entire Endsem paper. I hope you found this entire playlist helpful, and if you have any doubt, please drop it down in comment section. I will try to answer it. For this exam, for this solving this paper, I have used two references. That is O'Reilly book and Jan Pi's data mining book. Right. Thank you.